We've spoken a little bit about how the field of view of the lens is very important when it comes to projection mapping and solving for panoramas and tile worlds. So it's not always apparent how that comes into play until you've done it in practice. So let's solve an image for projection based just on one still. If we have a still image like this and we know the camera and the lens, which would give us the field of view for the camera and lens combination, and we have some survey information about the scene, some basic survey information, for example, the size of this antique chest or the distance between this box on the wall and this corner of the wall over here, or any 6 points of survey in the scene, we can pretty much solve the camera even with just one still. So let's do that using the camera tracker. It's not entirely obvious that it can be used this way, and it is in the documentation, but most people don't use it this way because they're typically solving for moving sequences and things like that, but it's possible to solve for just a still. So let's do that using user tracks here. So by default, there's no user tracks set up, and in order to use this, we're going to need a piece of it. What makes it easier to use is to have a piece of survey geometry that we've created that coincides with the survey we've done for our scene. So in this case, we had a very convenient thing to survey, which is this chest in the middle of the room. So I measured the chest and created a simple 3D object for it that is the same dimensions. That's our survey object. And we have an image of the box. Now we need to get the information into the camera tracker regarding the camera. And we can get that from the metadata, as we've learned in other classes. So we can look up the model of the camera and then look up the size of the image plane and the focal length of the lens. So this was 20 millimeters in this case. So let's start populating this with that information. Now in this particular case, Nuke now has presets for the camera that we're using. So we can just, for the size of the image area, the film back preset, we can pick a preset from this list. So I'm going to use Canon, DSLR, and in this case it was a 7D. We can see that from the metadata here. If I look in the metadata. There it is right there. So we've chosen that for our image back preset. We can select the lens as a known constant, which was 20 millimeters. And now Camera Tracker knows everything it needs to know about this camera to solve based on its field of view and some survey information. So we have this antique chest that we created, this model of it that answers to these survey information. So let's look at that. I've built the cube to be, Nuke uses meters as its units, so it measured to be 51 centimeters by 82 centimeters by 55 centimeters. So now we have this 3D box that's the same size. So let's look at the image here. And we can connect the camera tracker to it if we like, just so we can view the camera tracker while we're working. It's a good idea because the camera tracker will give us some little zooms when we create these user tracks. So let's get started creating the user tracks now that we have the camera information into the camera tracker node. I'll add a track, and I'm going to drag this track to this corner of the box. And while we go, I'm going to connect these to the antique chest in terms of as a survey point. So in order to enable it to be a survey point, I have to check this box here. Now, when I go into the 3D view, if I select the coinciding vertex on the box, I have to make sure that I have vertex selection mode enabled, and select that vertex and right click on it, I can attach it to my user track. So I'm going to snap that user track to this position in 3D. So I've told it this is the 2D position and this is the 3D position for that. So let's just keep adding tracks. I'm going to go back to my camera tracker, and we can add them in batches if we like. So let's add a few real quick. I'll add one there, and we can position it finally in this zoom in mode if we want, this reference zoom. I'll add that to the list of things I can pick. I'll add another one, user track 3. We'll put that there, kind of fine position it here. Add it to the list of things that are pickable. And we have to have at least 6 of these. So far I only have 3 or 4 at this point. So I'll have to get at least 6 for Nuke to create a solve based on these user tracks. We have to have both the 2D positions and the 3D positions. So before we go much further, let's attach these to the 3D positions. We've only done one so far. We have to attach 2. So we'll go back to the 3D view and we'll attach user track 2. We'll snap it to there. We'll attach user track 3 and we'll snap it to that corner. And we'll snap user track 4 to this corner of our box. And how many do we had? 5. So we'll get 5 snapped to that corner. And then we can create some more. Keep going. We'll add 6. And this would be the minimum we'd need to do a solve. I'm going to go ahead and make 7 of them. Since I can see 4 corners, I might as well or I can see all these corners, I might as well use them all. And it may increase the quality of my solve. So 6, and then we'll create one more, 7. That we'll put on this corner. Add it to the list. So back to 3D view. We'll snap 6 to this one. Oops, that was 7. Let's snap 7 to this one. And 6 to this one. Now all of my user tracks have a 2D position and a 3D position. So we'll go back to the camera tracker. Let's go view the camera tracker. And you'll see solve is now active because we have enough information, 2D and 3D information in the camera tracker to potentially do a solve. So let's see what we get. And it looks like it's solved. And we have a fairly high error, but because this is not a moving shot, that's not going to necessarily be a problem for us. Let's see how it's solved. If I if I create my 3D camera, so I'm just going to create just a camera there, and we view through the camera, make sure it's active, and we'll view through this camera, camera 1, and it looks like the box is pretty much in the same place. If we want to really validate this, we can set up a projection just to see if it's projecting onto the box. So let's start setting that up. We'll use a project 3D and we'll attach that to our camera as our projection camera and to our images here that we want to project. And then we'll attach that to our geometry and see how it lines up. And that's looking pretty good. It is projecting our box right on to our image, right onto our box. So if we jump out of this and go to the perspective view, I'm going to go to node selection so I get this whole thing and I can frame the whole thing in the default view and orbit out here. And we can see that camera, that looks about where you would expect it to be, and it's projecting it onto the box quite nicely. So let's finish building out this projection scene. Now that we've solved the camera, we've been able to reverse engineer where the camera was in the room based on the lens information and our simple survey box in this case. So let's view through the camera again, and let's set up another projection so we can start setting up a ground plane or something. So I'm going to set up another project 3D node. I'm just going to duplicate this one. attach it to the same camera, and for now let's attach it to the same plate, and we'll drop in a plane here, just a card, and we'll attach that card. And as you can see, the orientation of the card is not correct right now. It's needs to be pointing up like this, so we need to rotate it 90 degrees. And it's definitely not big enough, so let's scale it up a bit here before we even go into moving it around some more. Now let's do the rest through the camera, because we'll see more through the camera. Really what we want is we want this card to line up so that the corners of the room are lining up with the corners of the room here. There we go. So we've created a floor. As simple as that. Because we know the floor must be there, because if we look at it in 3D space, again, I'm going to jump out of here and jump to the default view. That's where the box was sitting on the floor. The box that we solved to was sitting on the floor, and hence the floor must be sitting below the box. So let's create some walls for this. We can use the same Project 3D node and some more cards. And if we'd like, we could just start with these same cards, but let's drop in a new card because we know they're oriented correctly right out of the box, and we'll just slide that back to the very edge of this one. And if these kind of jam together a little bit, it's not really that awful when you're doing projections, because they'll hide a lot of these problems. In fact, it's better than having a crack in there for it to kind of intersect just a little bit and crash with it just a tiny bit. And if we wanted to, we could move this card up, but I'm not even going to bother. I'm just going to scale it up until it hits the corner of the room there. We could do it from the 3D view here, or we could look through the other view. Really, if we put another card in here, when it intersects with that, it would replace that anyway, or it would cover that anyway, so it could even extend beyond that wall, and it wouldn't matter. Let's drop in another card. I'm going to copy this card. And now we know this card needs to rotate. The new card needs to rotate 90 degrees this way. So we'll make sure that we rotate along the right direct dimension here, or the right axis. And we'll nudge it back until it reaches the corner there. And now we have our back wall. Looking pretty good. Let's look through our projection camera again. And unfortunately, we don't have a very high field of view. But if this had been shot with a wider lens, or we could shoot another shot to fill this out a little bit more, you could get more of the room here. Okay, so we have our projection set up. That really wasn't so tough. But right now, if we look through the same camera that we built the projection from, it's not going to be very interesting. It's just going to look like the original photograph. Really, we want to look at it from a different angle. So let's create another camera, and we'll just make it sort of derivative of this camera. We'll take the same camera tracker and we'll create a new camera, but we won't link the output this time. So now we have a sort of camera born of this camera, same image sensor size, same focal length and everything. But let's go a little bit more telephoto on this lens. We'll go to like 30 millimeters, let's say. And so now this camera will this will be our projector. We'll rename it as such. And this will be our camera that we're going to shoot images from, and I'll call it cam main. So this is our render camera. So let's wire up everything here to a scene node. To do that, I'm going to select every piece of geometry I want to connect. I'm going to hit Tab and start typing scene. And now we've collected everything into one giant scene. We can drop down a scanline render node. And we want to connect that to the scene, the object scene input. And we want to connect this to our render camera. And the reason I built our render camera off the initial camera is that it will start from the same position as our projection camera. So everything will be perfect starting here. And then we can proceed from there if we want to move the camera off axis a little bit. So let's look through it. Let's look through the scanline render and see what we get. Go back to the 2D mode and solve and hide all these things so we don't have all these user tracks visible. And you can see, not very exciting because it will look exactly like the original image. So let's move the camera a little bit to the side. We're going to scoot the camera over to the, let's look at it through the 3D mode and make sure that we have cam main selected. And I'm going to hold down Control when I click the camera icon here to turn it green. And now when I edit the camera, I'm actually editing the position of the camera as I do it. And you'll see there's the problem of a shadow, because what happened is we haven't erased the stuff that was behind the chest, the antique chest. So we've got to touch this up a little bit.